An altitude connects the vertex of a triangle to the opposite side at a 90-degree angle, at a perpendicular. And what it does, basically, is an altitude measures the height of the vertex from the opposite side. Let's say we're looking at vertex B. The altitude, we look at the opposite side, and we draw a line that's perpendicular to that side and passes through vertex B. This essentially gives us the height of our triangle. But we could theoretically rotate our triangle. Say instead we were looking at vertex A with side BC. Well, we would draw a perpendicular to BC that passes through vertex A. Or we have another altitude. Say we are focused on vertex C with side AB. And there's another altitude. What we see, yet again, is that these three lines are concurrent. Before we talk about their point of concurrency, a good way to remember what an altitude is to think about where you hear altitude in everyday language. You hear it when we're talking about the altitude of a plane, or the altitude of a helicopter, the altitude of a mountain. All of these times when we use the word altitude, we're talking about the height, the sheer vertical height. So the altitude of a mountain, say we have our happy little snow-capped mountain. The altitude is not talking about the distance to climb up the mountain. The altitude is talking about the mountain's sheer vertical height. Or you can think about altitude on land. We're told that we're at a certain altitude, 8,000 feet above sea level. That's not talking about how far we are from the sea. It's meaning that wherever we are, that distance is 8,000 feet above sea level. Okay, the concurrency of altitudes. Here we have our triangle with our three altitudes that meet at point G. Again, we see that no matter how we change our triangle, all the altitudes always meet at point G. Something I want you to notice though, and we'll focus on the altitude from vertex B first. Let's get rid of the other two altitudes. We'll get rid of their right angles. And I'm going to extend, there we go, side AC. When my triangle's acute, we're happy. G is on the inside of the triangle, and my altitude is on the inside of the triangle. However, when my triangle's a right triangle, my altitude ends up being one of the sides or the legs of this right triangle. And the point of concurrency, point G, ends up being the vertex of the right angle. If I make my triangle obtuse, the altitude moves to the outside of the right triangle. Again, remember altitude measures height. So it's only interested in B's distance above this extended line. I can move it to the other side as well. No matter where B is, we just want its distance above this line. So altitudes can be on the inside of a triangle, they can be a leg of the triangle, or they can be outside the triangle. And we can go ahead and bring back, assuming I can find them. Oh well. That is our altitudes.